All right, we have finished our project and are ready to start the calculation side of Newton's second law. So for your warm-up today on October 4th, write down a real-life situation that involves either changing acceleration due to mass or force, depending on your seat number. So pause the video and try to write one. If you have a tough time thinking of one, think about like a car example is pretty good. So I'm going to give you some answers. For a car, let's say we have, say we have two cars, and let's say this one is full of people, and this one only has one person. Well, guess what? This one's going to accelerate faster, and this one's going to accelerate slower, because more mass equals less acceleration, less mass equals more acceleration. Changing force, if you gently press the brakes, you'll stop slowly, equals slow negative acceleration. Press the brakes quickly, like hard, push the brakes hard, that means fast. You'll come to a stop quickly, negative acceleration. So you change the force by hitting the brakes harder. Alright, today objectives. We're not going to quite get to this, but I think this is going to be probably your basic question on the test. Why do all objects with similar shape fall with the same acceleration regardless of mass? Number 2, given unbalanced forces, describe the type of acceleration the object will experience, positive or negative, and solve for the net force and direction. Vocab, we have newtons, unbalanced forces, force of gravity. Review, positive acceleration means increasing velocity, it's going faster. Negative acceleration means decreasing velocity, and this is acceleration due to gravity. The video we're not going to watch. Alright, so our title today, Basics, Newton's Second Law, page 11. So far we know. Well, we know that force is directly related to acceleration. So write that down and draw this graph. As force increases, acceleration also increases. That's a direct relation. So force increases and acceleration increases. That means they're directly related. So we're on page 11. Draw the graph and write these down. And 12, mass is indirectly related to acceleration. So write that down and draw this graph. Oh boy. Here we go. So here, mass is increasing, going this way, mass is increasing. While mass is increasing, acceleration is decreasing. That's the definition of an inverse proportion. Or, mass goes down and acceleration goes up, the other way around. So pause these if you need more time. Pause all the time to write stuff down. Finally, let's see Newton's second law. First thing, all objects, write that down, underline all, will only accelerate given the presence of an unbalanced force. All objects will only accelerate given the presence of an unbalanced force. And the rate of acceleration is directly related to force and indirectly related to mass. But you don't have to write down the second part. Pause the video if you need to finish your notes above, because it's all right there. This says force is directly related to acceleration and indirectly related to mass. That's why it's underneath on the division sign. For example, after your formula, write this down. If force doubles, then acceleration also doubles. Down here, it's indirectly related if mass doubles, then acceleration is now half. So let's try a couple. Let's look at some kind of proportional changes and see how the answers would be. So you don't need to write these down, just try to solve them. For example, our original acceleration is 4 meters per second squared. What would the new acceleration be if force were to double? Okay, think about it. First thing you want to think about, well, should acceleration increase or decrease? Well, I know if there's more force, that means acceleration should be greater. So I know it's increasing. How much now? Well, they're directly related, so if force doubles, acceleration also doubles, and you have 8 meters per second squared. What is the new acceleration then if force triples? Another way to mathematically look at it, mass is constant. This is 1. Force triples, so it's 3 times. So it's 3 times the acceleration, 3 times over 1. So if you triple this, that means we now have 12 meters per second squared. Let's try some more. What if mass doubles? Pause the video, think about it. Well, if mass doubles, if mass gets bigger, that means it's harder to accelerate, so force is constant, and mass doubles, so now it's 1/2 of the original, so this is 2 now. Let's try another one. What is the new force if mass is now half? Okay, let's think. If mass is getting smaller, acceleration gets bigger. How much bigger? Well, it's decreasing by a factor of 2. So that means acceleration increases by a factor of 2, and it's 8 meters per second squared. Alright, new thing, write down gravity, write down the formula. We won't worry about Aristotle today. So force times mass needs to be in kilograms, and acceleration needs to be, as always, 9.8 meters per second squared. This is blank kilograms, so what's the downward force of gravity this object feels? Some people needed this. If you did a lab that involved the circle and the weight over here, then you needed to find this force. So solve for it using the formula. The answer is 5 kilograms times 9.8 equals 49. And then the units are newtons. The units of force are always newtons, because it's easier than writing 49 kilogram meters per second squared. Other forces we need to know about. Let's move these out of the way. We'll cover these tomorrow in more detail. Friction opposes motion. Force applied would be like pushing, pulling, engine, or brakes. This could also be air resistance. Is a type of friction. And finally, we're looking at net force. This is really the net sum, and I want you to draw only the first one and solve for the net force. So draw this one. And what does F net equal? So I'm going to give you pictures and then pause the video so you can try to solve, and then I'll give you answers. So pause the video and draw it and try to solve it. Write down the definition too. F net equals 20 newtons to the right, because this feels 10 this way and 30 over here. So it really only feels 20 this way. You think about it like a tug of war. Next one. Draw that, or don't draw it, but just try to solve it. What's the net force? Pause the video. Here comes the answer. F net equals 30 newtons to the right, because the up and down cancel. Imagine you can't see this. Imagine this isn't here. Okay. If you are sitting in your chair and you're pushing down on your chair and the chair pushes back up on you, well, you don't really accelerate anywhere. There's no net force. The net force would be 0. So these two cancel. These cancel, and there's our net force. Okay, what's the net force here? Pause the video. Here comes the answer. Cancels, 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 and cancels. F net equals 0. And last one. Ooh, how do we do this one? First off, if this is north and this is west, what direction is it mostly going to be pointing? Yeah, over here somewhere. Should be a little more west than north because it's 4 and 3. Should be northwest. So can you solve for it now? Or maybe I should change it. Maybe I should say we have 3 newtons like this and 4 newtons like this. And this is your F net. So it's a squared plus b squared equals c squared. This is 9. 3 squared is 9, plus 4 squared is 16, equals c squared. 25 equals c squared, so c equals 5. Alright, for homework tonight, let's see. On page, you're not going to do this on page 10, do this on the bottom of your notes. In your red book, red and black book, page 93, questions 6, 7, and 8.